Okay, so today we are going to be doing law of sine. So we've been working with trig to solve right triangles, so now we're going to look at oblique triangles that can be acute or obtuse. So the way we labeled them is our uppercase letters A, B, and C are our angles, and the lowercase are our sides that are opposite. So side B is opposite angle B, side C is opposite angle C. So our law of sines is a set of proportions where side A over sine A equals side B over the sine of angle B equals side C over the sine of angle C. So we're going to use these proportions to solve the missing parts of a triangle. So if you look at example 1 in your slides, this is the triangle we're given. So we know angle B, angle C, and side B. So the things we're looking for, we're looking for the measure of angle A, we're looking for side A and side C. So if we think about this, so right off the bat we can think, okay, why don't we solve for the measure of angle A? I know a triangle is 180 degrees, so I can just subtract out, I know this will be angle A plus 102.3 plus 28.7. So if I just subtract these from A, I get the measure of angle A. Let's put it in our calculators. We get 49 degrees. So if we set up our proportion, it's going to be side A, which we don't know, over the sine of angle A, which is 49 degrees. Set that equal to side B, which is 27.4 over the sine of angle B, which is 28.7, equals side C, which we don't know, over the sine of 102.3. So this is our proportion. So we're going to use these to solve any missing piece. So if I want to solve A, I'm going to use this right here. So I'm going to say A over the sine of 49 equals 27.4 over the sine of 28.7. So we're going to cross multiply. So we'll multiply these and then divide by the sine of 28. So if we want to put this in our calculator, so it's going to be 27.4 times the sine of 49, and then I'm going to divide that by the sine of 28.7. We get A equals, is it 43.06. So A equals 43.06. So now if we want to do this for C, you can use A. I like to use the ones that we haven't figured out ourselves, like these were given to us, just in case we made an error with A. So for C, I'm going to say 27.4 over the sine of 28.7 equals C over the sine of 102.3. So I'm going to cross multiply here and then divide by the sine of 28.7. So 27.4 times the sine of 102.3 divided by the sine of 28.7. I get 55.75. So we have solved all the angles and all the sides of this triangle. So now let's try another example. So let's look at example 2 now. So we have, my picture's not perfect, but a right angle. They're telling us this is 8 degrees. This is C, A. So this, in the picture, this you'll see on the slides, this is a pole leaning. They want to know the length of the pole. So we want to use this whole angle here. So this would be 90 plus 8. So this whole thing is 98 degrees. So I'm looking for A. If I set up my proportions, I'm going to say side A over the sine of A, which is 43, equals side B, which we don't know, over, what is that? B would be 98 degrees equals C, which is 22 feet over side C, the sine of C, which we can figure out what C is because we can just subtract these numbers from 180. So we're doing 180 minus 43 minus 98. So it equals 39 degrees. So I'm going to change this to 39 degrees. All right, so, sine 98. So if I'm solving this, and I'm looking for A, so I'm trying to solve this, I know both of these numbers, so that's the proportion I'm going to use. So I'm going to say A over the sine of 43 equals 22 over the sine of 39. So I'm going to cross multiply and then divide by the sine of 39. So if you want to see. Okay. We get 23.84. And that is the length of A, which is what the question was asking.